we'll discuss one more example on how to evaluate the given double integral by changing its order. Okay. The given example is the integration from 0 to infinity and integration from x to infinity e raised to minus y divided by y dy into dx. Okay. As you know, the first integral limits, they represents the x limits. So x varies from 0 to infinity and y varies from x to infinity. Function is e raised to minus y divided by y dy into dx. Okay. As I said before, to change the order of the integration, first we need to find the region. Okay. Now, so what is our region now? That we have to check. What is it's giving? X varies from 0 to x. Okay. Now, x varies from 0 to x means this point is 0, 0, 0 to infinity. 0 to infinity means what? We can't mark the point because it is up to infinite. Now, y varies from 0, x, y equal to x to infinity. Y equal to x is what? Y equal to x is a straight line. Okay, it is a straight line equation passing through origin. So, y is equal to x represents straight line. Y equal to x and y varies to up to infinity. So, to infinity again along y axis we can't mark that. So, but what is the region? The region of integration is this. It goes up to infinite. Okay. This is our region of integration. Now, we need to change order of the integration. To change the order of integration, as I said, here x variables are constant and y has x limits are constant and y has a variable limits. Now, we'll change this order. Means x must have variable limits and y must have constant limits. For that, now x varies from here x varies from 0 to infinity. Now here x varies from 0, it starts from 0 only, but it depends on the value of y. Means x changes to 0 to y. And what about y? Y changes to y starts from 0. When x is 0, y is also 0 and ends at infinity. Means it varies up to infinity. So, therefore, by changing its order, what we'll get? Our I will be y varies from 0 to infinity and x varies from 0 to 1. 0 to y. And the function is e raised to minus y by y dx into dy now. Now the remaining procedure will be same. The normal integration, keep the first integral as it is. Y varies from 0 to infinity. Now integrate e raised to minus y by y with respect to, first it is with respect to x. So e raised to minus y by y acts as a constant. Keep it as it is. E raised to minus y by y. Then integration of dx is x. Limits varies from x 0 to y. So what happens here? It is integration from y to 0 to infinity. E raised to minus y by y. It is y minus 0. Okay, into dy. I forgot to write dy. Yes. Now you have to integrate with respect to y now. So the integral will be y varies from 0 to infinity. So it is e raised to minus y by y into y dy, y minus 0. So your integral, whatever it left, it is only e raised to minus y into dy. Now integration of this e raised to minus y is minus of minus e raised to y. Limits varies from 0 to infinity. So when you substitute upper and lower limits, what happens? minus of e raised to minus infinity minus e raised to minus 0. So it gives you minus of 0 minus 1. Therefore, what is the value of integral I? I is plus 1. This is the value of given integral by changing its order. Okay. This is how to solve the given integrals by changing its order. In the next class, I am going to solve the double integrals by changing them to polar coordinates. It will be given with a given in Cartesian coordinates, examples in the form of Cartesian coordinates. We need to change those Cartesian coordinates to polar coordinates. Okay. Till then, stay tuned. If you are not yet subscribed my channel, do subscribe and support. Take care. Thank you.